Welcome to this lesson on understanding lean and the 7 wastes. The 7 wastes is a core concept in lean production. So, let's get started on this journey. Lean is a philosophy that considers the expenditure of resources, for any goal other than the creation of value for the end customer, to be wasteful, and thus a target for elimination. In this unit, we will look at the 7 wastes. These include motion waste, time waste, defects waste, overprocessing waste, overproduction waste, inventory waste, and the final waste is transportation waste. Let's look at these in turn. Motion is a waste common in both manufacturing and service industries. This waste relates to movement within a process. In manufacturing, motion is easy to see. It occurs when a material, tool or person moves. The shorter the movement, the faster the process will be, and the more efficient the process. Some activities naturally have large amounts of motion built into them. For example, a warehouse pick operation requires an employee to visit different locations to fill orders. If the worker visits locations randomly, the motion between pick locations can be huge. If the pick routing is optimized, the worker will always move to the next closest pick location. Motion waste is typically a result of the physical design of a system. Some architectures place essential elements far apart, requiring a machine or person to move between the locations. In some cases, this is a result of efforts to make a process safe. For example, an operator may be required to leave an area before cycling a machine so that the machine doesn't impact the operator. In other cases, the designer didn't adequately consider motion when setting up the process. And what are the results of motion waste? Added motion slows processes, increases worker fatigue, and increases wear and tear on equipment. Motion also creates safety hazards, as greater movement of equipment risks impacting workers, and greater worker movement can lead to increases in strains and other injuries. Here are some solutions for motion waste. Reducing waste requires designing machines and work cells to minimize motion. This often requires layout changes, and is typically an early step in the adoption of lean. One important element in reducing motion is ensuring that tools are available where they are needed. This makes 5S a great program for reducing motion waste. Tools and other essential materials are positioned for optimal placement and minimal motion. All non-essential items are removed from an area. The result is a work cell that is more productive with much less motion. You can download an article on 5S from the references. Time wasting is one of the 7 wastes that most people recognize easily. The motivation to eliminate wait time has been the driving force behind many of the other wastes. When people think of wait time, most picture a worker in front of a machine, waiting for material to arrive or for the machine to cycle. This is one of the common types of wait time, but there are more subtle instances that are every bit as costly. Wait times are a major challenge in supply chain operations, as companies must wait days or weeks to replenish raw materials. Wait times also occur in many administrative functions, including the delays in the flow of information or approvals from one department to another, or the delay of waiting for an open position to be filled. The most basic cause of wait time is an unbalanced process. When one part of a process runs faster than a previous step, there will be waiting in the process. Another common cause of waiting is when materials are not available. This can be due to material handling processes not operating effectively or due to stockouts, as when replenishment inventory is out of sync with production. Other common causes of wait time are poor communication and poor decision-making processes. When employees do not have sufficient information and are not empowered to make decisions, wait time enters the process. This cause of wait time is extremely common in administration functions. The more bureaucratic an organization is, the more wait time due to slow communications and decision-making. And what are the effects of wait time waste? Wait time is pure waste, as a resource goes unused. This lost opportunity is easy to see, but is only one type of loss due to waiting. Most companies will not allow workers to sit idly for long periods of time. Even if the cause of waiting is not resolved, the company will usually seek to resume work. The effect of waiting is therefore a change in the plan, and resources are deployed to less than ideal uses to avoid wait time. Forced plan changes, resulting from a desire to avoid wait time, cause a wide range of the other problems. One common example is when a raw material is out of stock. The company cannot produce the product required by the customer. Instead, the company overproduces the products for which raw materials are available. Another common effect of wait time is to paralyze decision-making. When information is not available quickly, decisions cannot be made often. This leads to missed opportunities. By the time the information is available, the opportunity to use the information is no longer open. Even worse, when information isn't available, and a decision cannot be postponed, people will make less accurate decisions. Eliminating wait time is usually a straightforward process. Once the wait time is identified, eliminating bottlenecks is a typical strategy, as this allows for more balanced processes. When wait time is caused by slow communications and decision-making, the company requires structural change. Systems need to be upgraded to ensure information reaches the people that need it. The workforce needs to be empowered to make decisions, so that individuals do not have to wait for a decision to arrive. The most subtle causes of wait time are distractions that slow a worker's productivity. Eliminating potential distractions is an important step. Often, the distractions appear to be essential. For example, many employees set their computers to notify them when a new email arrives. This notification immediately removes the employee from productive work and places the employee in a wait mode, as the employee assesses whether they should act on the email now or later. Some companies have instituted email-free times, when employees shut down their email programs and focus on a single task. Tactics like this are common when implementing Lean in an office. Working to reduce or minimize each of these times can make your company more valuable to both its internal and external customers. Waste number 3 is defects. Poor quality, and the resulting defects, are a major source of cost for many companies. This is also a cost that is often underreported, as there are direct and indirect effects of defects. A defect is any error in a process that makes a product or service less valuable to a customer, or that requires additional processing to correct the defect. Defects arise out of processes that are poorly controlled. A well-designed process should produce acceptable results every time. Few processes can achieve perfect quality every time. Variations in raw materials, changes to machine setups, wear and tear on equipment, improper maintenance, poor training, and worker error can all lead to variations and quality defects. In an office environment, defects also occur. Poor planning, slow communications, and inadequate training can all lead to errors in work. Defects cause both direct and indirect costs. The direct costs are the lost materials and labor that went into the part that was defective, and the rework costs associated with correcting the defect. Indirect costs from defects can be crippling to a company. Every defective part that is produced uses capacity. When demand is high, and a bottleneck exists, defects will lead to lower revenues. If defects are not identified and corrected, they can reach the customer. A dissatisfied customer could be a best-case scenario, when you consider that substantial lawsuits are often a result of product defects. There are numerous examples of defective quality, leading to crippling liability awards in food, medical device, pharmaceutical, automotive, toy making, and other industries. And, what are the solutions for defect waste? Improving quality and reducing defects have been studied and refined over a number of decades. Poka-yoke is the lean activity, where a process is error-proofed. More recently, Six Sigma has grown out of the TQM movement into a set of tools for refining processes and improving quality. Overall, the lean methodology can be viewed as a set of tools and techniques for removing defects. Streamlining processes and removing waste are activities geared toward delivering consistent value with minimal waste. This can only be accomplished when processes are well designed and developed. to ensure high-quality products and services, with minimal expenditure of resources. Waste number 4 is overprocessing. Processing activities are typically viewed as value-added. It is the manufacturing processes that add value to the product and to the customer. Despite this, the process isn't valuable to the customer. The resultant change to the product is what may be valuable to the customer. This is an important distinction, because it is critical to assess every activity when eliminating waste. It is easy to assume a process in the middle of a production line is essential, but under examination, many processes are found to be unnecessary or overly complicated. The primary cause of some processing steps is a failure to recognize processing as a waste. Every process in the manufacturing operation is often assumed to be value-added. This leads individuals to overlook processing as a source of waste. The assumption is that the process wouldn't be there if it wasn't necessary. In reality, many processes are unnecessary. Another common cause of processing is complexity. The more complicated a process is, the more likely there will be unnecessary steps. As with the other wastes, processing adds costs. Each processing step introduces an opportunity for error. If you have hundreds of steps, each step will introduce opportunities for errors. Processing also slows an operation and extends lead times. Each step takes time, and more importantly, the wait time between steps greatly increases lead times. And what are solutions for overprocessing? The first step in eliminating processing is to recognize that processing activities can be wasteful. Most professionals overlook processing as a waste. Challenging these assumptions is critical to making your lean implementation successful. The next step is to look for ways to consolidate processes. If an activity is essential, look for ways it can be combined with other processes. This strategy often leads to the construction of work cells that combine operations. One of the most useful tools in eliminating processing is value stream mapping. Value stream mapping is a technique where a complete process is diagrammed in great detail, with processing times, queue times and batch quantities listed at each step. Completing a value stream map will often identify processing steps that are extremely costly, both in terms of resource costs and lead time increases. Value stream mapping is a technique where a complete process is diagrammed in great detail, with processing times, queue times and batch quantities listed at each step. Completing a value stream map will often identify processing steps that are extremely costly, both in terms of resource costs and lead time increases. Overproduction occurs when a company manufactures a product before there is a customer demand. Overproduction can occur with individual processes or across the entire value stream. The result of overproduction is excessive inventory, higher capital requirements, high obsolete and excess inventory expense, and additional product damage. Incentives can create an environment that unintentionally encourages and rewards overproduction. At the corporate level, the accounting policies will often incentivize overproduction. This is a result of the way companies account for expenses. Materials, labor and overhead are allocated to finished goods as product is manufactured. This is designed to properly tie expenses to the products that generated the expenses. Because overhead expenses are fixed, the time when the costs are absorbed does not change the costs. The result of tying absorption to production independent of demand is a system that encourages overproduction. Make-to-stock systems create overproduction by design. In a make-to-stock system, goods are produced in advance of demand. This is the definition of overproduction. Forecasting errors will cause overproduction. Organizations that manufacture to a sales forecast instead of actual demand will have errors. The errors will cause too much of some products and too little of other products to be made. The most obvious result of overproduction is an increase in inventory levels. This occurs as the extra production must be stored until it is needed or disposed of. In processes with bottlenecks, any overproduction of an item could result in a capacity or material shortage of another, more urgently needed item. Overproduction will often increase motion and transportation waste, as bigger lot sizes result in less efficient work cell designs, and more movement to and from storage locations. Overproduction will also increase the amount of obsolete and excess inventory that needs to be discarded. Here are some typical solutions for overproduction. Organizations can implement tighter controls on scheduling and forecasting, or shift from make to stock to make to order. They might also increase communication between the company, suppliers and customers, and aim to shorten lead times. Quality improvements will also allow for lower overproduction. And finally, redesign of the company's incentives to minimize overproduction and excess inventory can stimulate significant change. Inventory is recognized as a waste in the lean system. This is because inventory does not add any value to the customer, but has significant costs associated. Some versions of the 7 wastes refer to this waste as excess inventory, instead of inventory. The rationale for this is that manufacturing cannot operate with zero inventories. Although it may be impossible to achieve zero inventory, it is important to strive towards this goal. Practitioners should continually strive to reduce inventory, no matter how low the level. There will be times when further inventory reduction is not possible, or cost-effective with existing processes, but that should not lead to a permanent acceptance of inventory as necessary. Overproduction is a primary cause of inventory processes and incentives that encourage producing too much product, will lead to higher inventory levels. Poorly controlled processes lead to large lot sizes, inaccurate forecasts, poor communication with suppliers and customers, and bad management decisions. And what are effects of excess inventory? The most obvious effect of inventory is the capital required to carry the inventory. By reducing the inventory required to operate, the business can reduce the capital it requires in order to support those operations. As inventory levels go up, the capital investment in warehouse space also increases. Higher inventory levels also drive up obsolete and excess inventory expenses. Damage to inventory also increases as more inventory is stored for longer times. The larger the inventory, the more labor is required to maintain inventory accuracy. Here are some solutions for inventory. Every reduction in lead times allows a reduction in the inventory held. Eliminating work in process can be achieved by creating a seamless flow through the production process. Every break in a process requires work in process to be stored and moved between processes. Eliminating these breaks allows the elimination of work in process. Better forecasting and a shift to a pool-based scheduling system will eliminate the large forecast variances that lead to overproduction and increases in inventory levels. Any effort seeking to reduce inventory must have incentives to motivate employees to minimize inventory. This can involve charging a plant for the cost of capital, or by making inventory levels part of the bonus calculation. The most important thing to remember when looking at inventory is that all inventory is waste. Waste 7 is transportation. Transportation is the backbone of our economy, but it is also a fundamental waste to be eliminated. As important as it is to get a product to the customer, transportation does not add value to the product. This can be easily seen. Imagine you are in a store looking for product and find 2 identical products on the shelf. One was transported from a factory 500 miles away, and the other was produced 5,000 miles away. Would you be willing to pay more for the product that had been transported farther? Of course not. For many products, particularly perishable products like food, long transportation times can actually reduce the value of the product. The majority of transportation costs are generated by moving raw materials to a factory and moving finishing goods to a customer. In most industries, large-scale centralized production is the norm. The result is a product that may be produced hundreds or thousands of miles away from where it is needed. The supply chain has a big effect on transportation. Sourcing raw materials locally can reduce transportation costs. When making sourcing decisions, the transportation costs are typically included in the total cost of a material being acquired. Inside a facility, transportation is caused by wait time and inventory. Every break in a process that causes wait time has the potential to allow WIP to accumulate. As WIP accumulates, it needs to be stored, and in turn, transported to and from storage locations. With high finished goods and raw material inventories, transportation costs also rise. Transportation costs money in equipment, fuel and labor. Transportation also drives up lead times. This is most commonly felt with imported raw materials. Transportation also drives up other costs. Every time a material is moved, there is a potential for damage. Securing a product for transportation also requires labor, as the product must be stacked and packed to minimize damage. For products shipped outside a facility, theft and security costs are also a factor. Companies strive to develop supply chains that minimize transportation and other costs. When implementing lean in a facility, any effort that streamlines a process should reduce transportation. Combining operations and eliminating a wait step will reduce work in progress, and the handling of that work in progress. Reducing lead times will reduce the amount of inventory held, and reduce the transportation of that inventory to and from storage locations. The biggest steps a company can make are likely to be the development of process lines that transform raw materials into finished goods, without any intermediate stops, along with a make-to-order scheduling system. In this case, raw materials are the only items that need to be stored. Lean is a philosophy that considers the expenditure of resources for any goal, other than the creation of value for the end customer, to be wasteful, and thus a target for elimination. So-called waste elimination is one of the most effective ways to increase profitability in many different kinds of businesses. So, what is waste elimination? Waste is simply any wastage of time and resources that could have been avoided with focus, planning and effective execution. In other words, we often have the scope to eliminate, or at least reduce process waste, and in so doing we can generate more profit for the enterprise. While products and services obviously differ in various organizations, the typical process wastes found in quite varied environments are quite similar. This may include wasted supplies, or too much inventory, wasted effort or having to rework jobs or products, quality problems, wasted materials, underutilization of assets and many, many more. There are a number of activities to complete for this unit. Take the time to complete these in your manual. In this way, you will better learn from and retain the knowledge covered in this unit. Thank you for watching this lesson. We hope you have found it useful. Visit our website to view our range of courses on operations and quality management.